Hello and welcome. We go a step further today in our lesson to look closely at other features or properties of linear equations. Let's begin. By now, we have become convinced that linear equations are equations of straight line. In other words, linear equations describe straight lines. So when you have a linear equation, it's actually telling you that this is a straight line. So how then can we look at this straight line? One of the ways is by plotting the values of x against y on a two-dimensional plane consisting of two axes, a vertical axis called y-axis and a horizontal axis called x-axis. So we want to see what are the properties of linear equations when they are plotted on this two-dimensional plane. We are going to consider two or three equations, or let's say four equations. One of them is a linear equation, the others we have termed them as non-linear equations. I want to see the two of them and compare them. Okay, recall that we started with the equation y is equal to 2x plus 3, and we said this is a linear equation. In other words, it's an equation that describes a straight line. Now we also like to test y is equal to 2 over x plus 1. We'll also like to look at x over y is equal to 1. And lastly, we'll also like to look at y is equal to 2x squared plus 3. Okay, we'd like to see what exactly do these look like. Okay, so one way to plot the graph is to explore the values of x for y. In other words, plug in some values for x and see what the corresponding y values will be, and then you put this in a table and then you plot it. Okay, now let's do that. So we're going to choose some values are negative, some values are positive. So we're trying to stay in the middle. So we're going to make 0 our middle point. So we're going to have values of x as 0, 1, 2, and 3. Then we also have values of x as negative 1, negative 2, and negative 3. So if we plot in negative 1, sorry, plot in 0 as x, so that means y will be equal to what? 2 into 0 plus 3. So therefore y is what? 3. Okay, so y is 3. Y is equal to 3. So what of when x is 1? So y will be what? 2 into 1 plus 3. So that is 2 plus 3. So y will be what? Y will be equal to 5. So what about when x is equal to 2? 2 into 2. Okay, that's 2 times 2. That is 4. 4 plus 3. So that is 7. Okay. Next, now let's do the negative numbers. Sorry, let's do one more. Y is equal to 2 into 3. 2 times 3, that is 6. 6 plus 3, that is equal to 9. Okay, if you look at something here, 3 increases by 2 to 5. 5 increases by 2 to 7. 7 increases by 2 to 9. So there's a consistent increase in the value. It changes by 2. We're going to talk about that. So next, let's try and plot the value of y is equal to, when it's negative 1, 2 times negative 1 gives us negative 2. Negative 2 plus 3 gives us what? 1. Okay, value of 1. So when y is equal to negative 2, so 2 times negative 2 gives us negative 4. Negative 4 plus 3 gives us what? Negative 1. Okay, what about when x is equal to negative 3? 2 into negative 3 plus 3. Negative 3 times 2 gives us negative 6. Negative 6 plus 3 gives us negative 3. Okay, so now we have several values. So what we can do with these values is to write it in a table. So we can make a table of x and y. Okay, so let's start from the extreme left where we put the negative values. So negative 3, negative 2, negative 1, then we have 0 in the middle, 1, 2, and 3. So those are the values of x. So when x is negative 3, what is the value of y? That's what we see here. So when x is negative 3, the value of y is negative 3. Okay? When x is negative 2, the value of y is negative 1. When x is negative 1, what is the value of y? The value of y is 1. When y is equal to 0, the value of y is 3. When y is equal to 1, the value of y is 5. Okay? When x is equal to, sorry, that's x. When x is equal to 2, then the value of y is 7. And then when x is equal to 3, the value of y is 9. So what we have is, now we have a table of x and y. So we can now plot this table of x and y on a graph that has a y-axis as well as an x-axis. Okay, so let's make the table. The first thing is we look at the table. The maximum value of y is negative 3. The maximum value of y is 9. So we're going to, let's make a long arrow for the y. Well, the y is in the vertical direction, while the x is in the horizontal direction. So this is the x. Remember to label the axis, x and the y. So now let's label, so we know that, so let's label, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then for the negative axis, that's 1, 2, 3, 4, 5. Okay. So this is negative 1, negative 2, negative 3, negative 4, negative 5. Okay. This is 1, 2, 3, 4, 5, 6, 7, 8, and the 9. Okay. And then on the x-axis, we have negative 1, negative 2, negative 3. Okay. On the other side, positive axis, 1, 2, 3. Well, sorry, I should use the same scale, but this is just a rough sketch for you to get an idea of what we need to do. Okay, so when x is equal to negative 3, y is also equal to negative 3. So x negative 3, we see here x here, this negative 3 here, and then y is negative 3. So wherever the two of them meets, so we see here, this is the point for negative 3 on the x-axis, and this is the point for the negative 3 on the y-axis. So if you draw a line from the x to the y, the point where they meet is where we place our point. Okay, so now let's do that. So let me use a different color so that we can appreciate it. So negative 3x to negative 3y. So we're going to put the point right there. Okay, right there. Okay, so when x is negative 2, y is negative 1. Okay, so x is negative 2, so we're going to put our point right there because that's where negative 1 is. Okay, so when x is negative 1, y is positive 1. So negative 1, positive 1, that is where we put our next point. So when x is 0, y is what? Positive 3. So our next point is going to be right there. Okay, so when x is 1, y is 5. Okay, so that's 1 and 5. So when x is 2, y is 7. 2 and 7. And when x is 3, y is 9. So 3 and 9. Okay, now we see here, what we see here is what? The number of dots that goes in a straight line. So if I try to use freehand to connect these, should get a close approximation to a straight line. Okay, Well, that's a free hand. It's not as straight as it is, but if you draw a real straight line, it's going to be a straight line. So here, what we have here is what? Our equation of a straight line, which is this y is equal to 2x plus 3. Okay, y is equal to 2x plus 3. So what if we want to try y is equal to 2 over x plus 1? I want you to pause the video and find the values of y for the equation y is equal to 2 over x plus 1, using when x is, you start the values from -3 up to +3, just like we just done. Okay, now we have the values, the table values for y is equal to 2 over x plus 3. So we have the values of the x above and the values of the y below. Well, by just looking at the table, you can tell that this is not a straight line. If you look at from 0, for example, first I want to say that when you plug in 0, 2 over 0 is going to give you an undefined value. So I'm just assuming that, let's assume that 2 over 0 is 0, but we know that it's undefined, isn't it? So that gives us a value of 3. So if you go from 0 to 1, so 0 to 1, that is a difference of 2, right? That from 3 to 5, that's a difference of 2. Then from 5 to 3, so there's a difference of -2. Okay, then from 3 to 3 2/3, that's a difference of positive what? 2 over 3. So we see there is no constant change as you go from one value to the next value. It's kind of haphazard. Okay, if you look at in the negative direction too, from 3 to 1, that's a change of what? -2. Then from 1 to 2, that's a change of +1. Then from 2 to 2 1/3, that's a change of what? +1 over 3. So we see a kind of haphazard change in the values of y. Okay, now let's quickly put this on the graph. So if we make a quick graph, we're not going to draw it to scale, just for us to see what it's like. Okay, so if x is -3, so let's say this is where -3 is, and then y is +2 over 3. So let's say this is 1, 2, and 3. So +2, 1 over 3 is like 2.3, just about a third of the way there. So that's where that is. And then -2, and this is -3. So -2, when x is -2, then it's +2. Okay, this is +2. Okay, so when x is -1, y is what? +1. So that's a +1. Then when x is 0, when x is 0, y is sorry, did I say positive? This is wrong. When x is -1, then y is +1. Yes, that's correct. Sorry. Then when x is 0, y is +3. So this is 0 and then +3. Okay. Then when x is 1, y is +5. So if this is 4, and that is 5. So when x is 1, so this is 1, y is what? 5. Okay, so we're going to mark that point. So when x is 2, and so when x is 2, y is what? Y is 3. So it kind of falls back down to 3. So when x is 3, then, and that's 3 2/3, then it slightly rises again, 3 2/3. So we can't join this in a straight line, so technically it's like that, and like that, and like that, and like that. So we see that this equation y is equal to 2 over x plus 3 does not give us a straight line, because of that property that we talked about of straight lines. Let's quickly look at one of the other examples, I'm going to allow you to try the x over y is equal to 1 by yourself, but let's try the one with y is equal to 2x squared plus 3. So by plugging values from -3 to +3, we were able to make a table that looks like this. So x and y. So -3, -2, -1, 0, 1, 2, and 3. So for -3, the value of y is 21. -2, the value of y is 11. -1, the value of y is 5. Then for 0, the value of y is 3. Then for 1, the value of 1 is 5. Then for 2, the value of y is 11. And then for 3, the value of y is 21. So we can see that for -3 and +3, they have the same value, 21, 21. So is this going to be a straight line? Let's check it out. Okay, so let's plot a graph. That's rather too big. Let's create some space. So let's plot a graph. So this is the x and that is the y. So when x is -3, so let's assume this is -3, y is +21. So let's make 21 the highest because it looks like that's the biggest value there. So x is 21. Then when y is 21, so when x is -2, y is +11. So 11 will be somewhere around there. So that's 11. And then when x is -1, y is +5. So +5 will be somewhere there. And then when x is 0, y is 3. So we're going to put it close by there. And then when x is 1, y is equal to 5. So that's a change in direction. When x is equal to, that's 1. When x is equal to 2, then y is equal to 11. Okay, so that's 11. Then when x is equal to 3, it becomes 21. So what we have here is a curve which we call a parabola. Okay, so we see that this is also not a linear equation. So we've been able to see by testing that all those rules, and the reason why those rules are there or those properties are there is so that you'll be able to recognize linear equation from other forms of equations. Now let's look again at our first equation, y is equal to 2x plus 3. And this is the table that we obtained when we plugged in different values of x to find out the corresponding values of y. Now I want us to see something that I've mentioned in passing, but I want us to look closely at that. So that is the rate of change as you go from one value of x to the next value. So if you look at this table, between 0 and 1, there's a change of 2, +2. Between 1 and 2, when I say between the change of value of x from 1 to 2, the value of y changes also by 2. Then when you change the value of x from 2 to 3, the y changes also by a value of 2, which is consistent. If you look at the negative side, the same thing applies. Why is that? How did we find that? Well, the change can be calculated as the difference in y minus y1 divided by x minus x1. Okay, so let's say, so the final value of y, let's say we are going from 0 to 1, isn't it? So we're going to, what's the y value for 1 for when x is 1? So that's what we're going to write for. So that we're going to write the bigger value for 5 minus what is y1? That's sorry, what is y1? That is the first y, that is 3. 5 minus 3 divided by what is the first x, that is 1, and what is x1, that is 0. So 5 minus 3, that is 2 over 1, that is 2. So that's how we know the difference, the change, between x and y. So what we see here is that there's a constant and consistent change as you go from one value of x to the next value of x. The value of y changes by a constant value. But that is not so for nonlinear equations. There is always an inconsistent change or a reversal, or some other things do happen there. Like in the parabola, we noticed that the numbers coalesced at a point and then they change directions. So the same way, when you are looking at linear equation, one of the properties that you are looking at is a constant change as you go from one value to the next. So as a recap, we looked at one fundamental property of linear equations, which is a constant change as you go from one point to the next point. In other words, as you go from change the value of x from one value to the next value, there's a constant change also in the value of y. In other words, y changes by a constant value. So if you go from 1 to 2 for the value of x, y may change only by 2. And when you go from 2 to 3, y may also change only by 2. So there's a constant change as you go from one value of x to the other in the corresponding value of y. That is a very valid property of linear equation. However, nonlinear equations don't have that property, and that's what makes them different from linear equations. And lastly, we know that linear equations are equations of straight lines. That's it on linear equations part 2. Thank you for watching.